Okay, Algebra 2. This is our relations and functions notes. We're talking about a set of ordered pairs. These ordered pairs can be shown as a table, as a mapping diagram, as a graph, or expressed as an equation. Okay, the set of x values is called your domain, and the set of y values is called your range. A relation with distinct points is called discrete, and a relation with connected lines or curves is called continuous. All right, now we're going to take a look at some ordered pairs, and we're going to discuss whether or not they are functions or not functions. So give me a second, I'll write those on there, and then we can talk about them. Okay, here we're looking at some ordered pairs. We need to, in order for it to be a function, we need to make sure it satisfies this definition. Each element of the domain is paired with exactly one element of the range. Okay, so let's take a look. If I look at my green points here, I have the input values of 0, -5, and 6. And are they paired with exactly one output? Yes, they are. So this meets the definition of a function. Now let's look at the not a function pairs, the red ones, and we will look and see why this is not a function. Does every element of the domain, does every x value pair with exactly one element of the range? Well, no, it does not, because if you look at this 6 right here, it is not just paired with one element of the range. This 6 is paired with a -1, and this 6 is paired with a 5. You cannot have that and have a relation be a function. So that is why that one is not a function. All right, we can also use a vertical line test to determine whether a function is a function. Okay, so we're going to take my red line. This will be my testing line here, and I'm going to run it across this green graph. And when I do that, it should only touch that graph in one spot. No matter where I put it on the green graph, my red line should only touch the green graph in one spot. It does. It only touches it no matter where I put it. No matter where I run it across this graph, it is only in one spot. So yes, this one is, in fact, a function. Okay, let's take it over to the not function, the blue one, and we'll see why it is not a function using our vertical line test. As we put this red line across my blue graph, I see that it touches the graph in more than one spot at the same time. So if we look here and here, that means this x value here has the output of that y value, and it has the output of that y value. So that means that that input value has two different output values. So that's how we use the vertical line test to determine whether or not something is a function. And as we can see, this one is not a function. Okay, let's take a look at some example problems. I'm going to leave the even problems for you to do. I'm going to look at the odd ones. So let's see. As we said before, the x values is your domain values, and the y values are your range values. So we'll do this, x values. And my x values in these ordered pairs are -1, 0, 4, and 6. And my range values, remember those are your y values, is going to be -9, -5, 3, and -2. Now we need to determine, is this a function? Does every x value pair with exactly one y value? Well, I'm looking at my x values here, and I don't see any of them repeating, and I don't see where, like, if I don't have another -1, obviously it isn't paired with another y value. So at this point, we can say, yes, this one is a function. Okay? So again, let's take a look at number 3. Let's take a look at our domain value, or our x values, or these numbers right here. So we 7 to 0 and -4. And my range values are my y values, which are those numbers right there. So I have -8, 3, -1, and 3. So let's take a look and see, does every x value pair with exactly one y value? Well, again, I don't see any x values repeating here, so it looks like that, yes, again, this is a function. Every x value has exactly one y value. All right, let's take a look at number 5. My domain values are my x's, so I'm going to list those as -4, -2, and 5. And my y values are my range values, so I'll list those 0, 3, 7, and 9. Is this a function? Well, we need to look. Does the input values, does the x values, does this go to only one y value? So if you remember correctly in a mapping diagram, each x value is paired with an arrow to its output. And as you can see right here, that 5 is paired with not just 7, but also 9. So that means that the input value 5 has an output of 7 and an output of 9. So that means that no, this one is not a function. Okay? So let's take a look at number 7. I'm going to write my, my ordered pairs for these guys. So this guy right here is going to be -3, 1. This guy down here is going to be -3, -2. This one up here is going to be 0, 1, 2, 3, 4. This one right here is going to be 2, -1. And I have one down here, and this one is going to be 1, 2, 3, 4, -5. Okay, so let's go ahead and list our domain and range values. My domain is going to be -3, 0, 2, and 4. And my range values are my y values. I have 1, -2, 4, -1, and -5. Okay? So we need to determine, is this a function? Well, I can use the vertical line test here. I'm going to go across my points, and if my red line touches any of those points at the same time, then it would not be a function. So as we can see here, yep, right there, my red line touches those 2 points at the same time, so we can say, no, this is not a function. Okay, because my input value, -3, has 2 different output values. Okay, so what can we notice about number 5 and number 7 that are similar when we're talking about domain and range and whether or not a function is or a relation is a function? If you look on number 5, we have 1, 2, 3 domain values, right? We have 3 domain values. And then we have 1, 2, 3, 4 range values. Okay? So we have 3 domain values and 4 range values. Let's look at number 7. How many domain values do we have here? 1, 2, 3, 4. And how many range values do we have? 1, 2, 3, 4, 5. So there we go. This should tell you that anytime you have more range values than you do domain values, you're not going to have a function, because that means that one of your domain values goes to 2 different range values. And that is an indicator that no, this is not a function. Okay? Let's look at number 9. Here we have a continuous function because all of our points are connected with a smooth line or curve. And so we're going to use the straight or the vertical line test here to see if when I run this red line across this graph on number 9, do I touch this graph in more than one spot? So taking my vertical line over, as you can see, yes, it does touch it in more than one spot. So it touches here and here. So this is not going to be a function. We're going to write no down here. So now that we've determined that it's not a function by using our vertical line test, let's take a minute and talk about the domain and range, because it's not as simple as it has been in the previous problems. Now we have to understand that we're not just talking about specific points on this graph. We are talking about every single possible x value on this line, okay, when we're talking about domain. So I need to somehow indicate that all of these x values from here forward need to be represented somehow in my domain when I write my domain. So this x value right here is negative 1, 2, 3, 4. This x value right here is negative 4. That's the lowest x value that I get to. Okay? Now I need to indicate in my domain that I need to include every x value from that negative 4 to infinity in the positive direction. So I'm going to write that as x is going to be greater than or equal to negative 4. That's going to be my domain for number 9. Okay, so my range values then, let's talk about the y values. My range values, I need to see, is there a stopping point? Like here's a stopping point for my domain. Is there a stopping point for my range? Is my graph going continually up forever? Yes, it is. Is it going continually down forever? Yes, it is. Okay, since it's going up and down, we can say that the range is all real numbers. All of the y values from here to infinity will be used in this graph at some point. Okay, so my range is limited. It's going to be x is greater than or equal to negative 4, and my domain is limited. X is greater than or equal to negative 4, and my range is continuous, so it's going to be all real numbers. All right, so for number 11 and number 13, we're going to use Desmos, and we're going to look at the graph and determine the domain and range and whether or not it's a function from Desmos. Okay, here we have the equation y equals negative x squared plus 3. Okay, so we need to talk about the domain, we need to talk about the range, and whether or not it is a function. Okay, so our domain, our x values, these actually have arrows on them. They're going to continue forever and ever to the left and to the right. So our domain, there is no limit to our domain. It's going to continue forever and ever to the left, and it's going to continue forever and ever to the right. Okay? Slowly, but it will continue forever and ever to the left and to the right. So in this case, when it's continuing forever and ever to the left and to the right, we're going to say that the domain is all real numbers. Now the range is going to be a little bit different. My range has a limit. Okay, it goes to a certain y value, and then it stops and it changes direction. Okay, it gets to a certain y value, then it stops and changes direction, and that place where it changes direction is right here at y equals 3. Okay, so we want to somehow say that this y value 3 and all of the y values below it are going to be on this graph. So I'm going to say that my range values are my y values less than or equal to the y value 3. Now, is this a function? If I took a vertical line, get a green vertical line here. If I took a vertical line and I took this vertical line and I ran it across this graph, is it touching that graph in more than one spot? No, it is not. So yes, this is a function. Okay, we no longer need the question mark. We know that it's a function, so yes, it is a function. Okay, for our last one, for number 13, we have y equals negative 7. So our domain in this one, remember this has arrows on both ends, even though it doesn't show it on Desmos. Our domain, are we going continually forever and ever to the left and continually forever and ever to the right? Yes, we are. So when we go continually both to the left and to the right, that means my domain is all real numbers. Okay, my range, this one's a little bit different also. If you look, all my y values are along this line. And what are all those y values? All those y values are 7. They don't change at all. So in this case, my range is not going to change. It's going to be y is equal to 7. Okay? Now, going to get another vertical line here. Give me another green vertical line. I'm going to run it across this graph. Remember, it's not a function if my green line touches my red line in more than one spot. Let's get rid of all these blue y values here. Does it touch this red line in more than one spot as I run it across there? No, it does not. So yes, it is a function. Okay? Thanks for hanging with me, and I hope you enjoyed the relations and functions notes.